In this section, we're going to have a look at microphones, how they work, and what the key differences are between the three most common types you'll be using for your recording. Before we do that, however, we need to know what a microphone actually is and how it works. A microphone is a type of transducer, in other words, a device that converts one form of energy into another. So, in the case of a microphone, it takes acoustic energy in the form of a sound wave and converts it into something that we can capture as a recording. It does this by converting the acoustic energy into electrical energy. All microphones convert energy, but that's not all they share in common. All microphones have something called a diaphragm. This behaves in the same way our eardrums work. An eardrum consists of a thin membrane that vibrates when sound hits it. A microphone's diaphragm does pretty much the same thing. A diaphragm can be made out of different materials: plastic, very thin metals, even paper, and is always found in the head of the microphone. Here we see a microphone without its protective grille, and you can clearly see the small circle in the centre of the head. That's the diaphragm. Along with the diaphragm, a microphone has a transducer, which converts the acoustic energy into electrical signal, and a casing. The casing isn't just there to protect the microphone. It can also be designed in some instances to make a microphone pick up sound in some directions and not in others. This is known as a microphone's polarity, and allows the engineer to focus the microphone on particular areas of the sound source and be relatively deaf to other areas. Microphones can emphasize certain frequencies or groups of frequencies either by design or through other means, either electrical or mechanical. This is known as the microphone's resonant frequency. Some microphones have very little resonant frequency characteristics, giving a much flatter recording result, and some have quite noticeable frequency characteristics and colour the sound considerably. Both have their part to play. Indeed, a lot of engineers have favourite microphones for particular instruments because of this effect. Whatever your needs, it's always worth checking your microphone's particular characteristics before recording. And try out different mics on the same sound source and see which one you like. And more importantly, what difference each one makes to the sound. So to recap, when the diaphragm of a microphone vibrates, it causes other components in the microphone to vibrate also, which in turn leads to the conversion of sound into current. The key factor is how a microphone converts this energy. And the three common types of microphone you are most likely to encounter are dynamic, condenser, ribbon. Each has advantages and disadvantages, and it's important to understand the differences between each one, so that you can start to make informed decisions about what mic should be used for what task. Let's start with a dynamic microphone.